Okay, I think we're good to go. Hope everyone is here. Hello, welcome to another session of the Tech Savvy Talks by Scalefocus. So if you're not introduced to this before, so we have these Tech Savvy Talks about every 2 weeks where we discuss different topics. Today's topic is going to be bringing order to chaos, as I like to say it, or how to create and approach a cross-platform automation framework. So we'll talk more about that, how we can approach it, how to create it. A little bit about myself. So I'm a quality engineer. Main focus is in automation and usually using .NET to do that. To be honest, it just gets my creative side much more engaged. I have about 4 years of experience, and most of my free time, if I'm not coding or looking for new solutions to already existing problems, then I usually just play some computer games or enjoy some sport activities. Okay, so just so you know, the session will be recorded. I think maybe Zoom already prompted you to that, but yeah, and you will get a link somewhere down the line to the video itself. In the end, we'll have an interactive Q&A session using the Slido platform. If you're interested, you can join the Slido platform now. It's hashtag TechSavvy, and you can, as you come up with questions about the presentation, feel free to post any questions there, and we'll address them at the end of the session itself. Okay, so what are we going to talk about? Well, we're going to start with the initial idea of how this project came to be, and then I'm going to take you on a ride on how it evolved, what we did to get where we ended up. Then I'm going to talk about what we're using, what technologies we're using to do it, and then I'm going to talk about 2 of the approaches that seemed most likely to do this project, and we'll talk a bit more about the pros, the cons, which one we went with, and why we went with that one. In the end, we'll talk about the CI/CD implementation, how we did this, how we implemented it so that it goes so smooth. And for the end, I will just show you some of the reports that we were using, how they look, what they're good at, and stuff like that. The last thing will be the next steps that we can take to make the application even more advanced. Okay, so let me take you on a journey. So the story starts, we're having a very good client. We have a web application, it runs smooth, everything is great, and then it starts getting some traction. So the client comes and says, okay, our web application is going great, but I think it's time to expand. Let's go mobile. So let's expand it more. Okay, so this is where we start getting new people and we start thinking, okay, how are we going to test that? So we did like an initial idea of what we're going to do it. So we wanted to keep it all in the same place. So one solution, not keep it all over the place. So we have one centralized place where we have everything. And then maybe we can split it into multiple parts, as you can see here. So the first initial idea was we were going to have like one project for the base framework. So this would be like the general framework, but that we're going to use our separate custom web framework, separate custom API framework, and our API framework. So this is where all the main stuff would be, how all the initial logs, how we're going to set up the solution, everything would be done here. Then we imagine that we would have the tests themselves. So there would be a separate project. And then we would have this DeltaSky, that's how we called it actually. The application itself. So this DeltaSky would communicate through a service, which would, the initial thinking was we would send like a JSON of what we want to execute, how we want to execute these tests. And then the service would just chunk up that JSON and then send all the tests that need to be executed. And then the tests themselves would start up Kubernetes pods that would then start those tests. Then they would return the results back to the test, and then through the service, we will get them into DeltaSky. So as you can see, it's a pretty complex process. And the first thing we did, so why does it need to be this complex? So we went on how we can make it more simple. And the first thing was, well, let's remove the service. The DeltaSky itself can act as that. So there's no need to have an additional service to jumble up all that data. So we can directly send that to the tests, which at start looked very good. But the next thing is, okay, so when the developers push another code, we want to be able to run these tests. And now the thing would be, well, we have CI/CD for that. And the CI/CD itself starts their own machine. So why would we need separate Kubernetes pods to do that? So of course, the next step was to remove the Kubernetes pods as well. And our solution looks much more tangible, much more easier to implement, easier to use. However, we noticed that something is still missing. And that's where all the, so we already have a place where we put the tests and a place where we put the framework. But what's the in between? We still didn't figure that out. And this is where we actually put the entities project, as I like to call it. It's where we had everything, the helpers, the contracts, the pages, screens, etc., etc. So everything we will need to create the actual test, the actual methods for the test, that would be in this entities project, which could be separated into multiple projects itself down the line. Okay, so we had the idea. The next thing was to start, okay, what are we going to use? Which technologies are we going to use to do this? And well, programming language, it will be the C#. We're most introduced to that one. That's how we started everything. So we decided to go along with that. Use the .NET 5 framework. The unit testing framework, we already started with NUnit, so there was no need to change from that. It perfectly satisfied our conditions. For logging, we have Log4net. Now for browser automation, we went with Selenium, most common one. We won't go to Selenium 4 now, so not much to speak of there. For mobile automation, we were thinking about multiple, like Espresso, Appium, XQCI, and in the end, we went with Appium because it's easy to adapt it to C#, and we can just write everything into one solution, as I said in the start. So it just makes sense to go with Appium. For API automation, we went with REST Sharp. Of course, it's C#, so it made the most sense to went with this one. It's the most popular one people are using. For CI/CD, we went with AWS. And for reporting, we went with Aware reports. So we will speak more about those down the line. Okay, so let's see two approaches. What are they and why did we went with those ones? The first one is the attribute-based approach that we first went with, but didn't choose in the end. The thing with this one is that we would have one test class and one test for all the platforms. And the attributes of the test itself, if you're on Java, it's the annotations. They will decide what platform the test will run on. So we will just put like different tags on the test themselves, and those tags will decide where we would have our test run, on which platform. Now, the DeltaSky approach, on the other hand, didn't take this into consideration. So we didn't have tags to tell us where to do it, but we would have different test classes for different platforms, depending on the number of platforms. And each in these test classes would have separate tests created specifically for each platform to do that platform the good it does. Okay, so how did we decide what's the best way? I mean, what's the better one from both of these? So we went with the, let's first see the attribute-based approach and the pros. So what's the pros? The tests are all in one place. So you need to search classes, go through the whole project. What class are these tests in, how do I find them, I can find them and stuff like that. They're all into one place. So you can just Control F and you can find them without a problem. Now, because all the tests are for all the platforms, it's easier to change the flow of tests. So if we have them on different platforms, we would have to change each test separately. However, here it's easy. We have one test. It's much easier to test. You don't need to search through other tests. It's just that one test is going to change. So that went much more smoother. And with that came that it's easier to write test cases themselves. So you didn't need to. This is also a great way to use Cucumber here. So you can use the Cucumber approach to create the test case. So it was very, very fast in that sense. However, the cons are more not how the tests themselves are created and stored. It's what's underneath all that. So first, all test cases don't make sense for all platforms. For example, changing the language. It makes sense for web. It makes sense for APM, for Android, for iOS, but that doesn't make any sense for an API test. So we would have extra tests here, or tests that are not for all platforms. And then we would have different tests. Some are for this platform. Then we have the same test, but differently written for another platform because we can't adapt it that way. So a lot of problems arose here. Next thing would be all tests being in one place goes against more popular designs like page object model, screens in mobile testing. So we won't have that because if they're all in one place, we can't make our own. We can't use those design patterns. We have to use other design patterns, and it's much harder to find any internet knowledge on those patterns because they're so rarely used. So the next thing would go, we would need a lot of processing time to find all the attributes on the test. So I'm not sure if you work with NUnit, but NUnit allows you to actually access all the attributes that are on a test. So in order to access these attributes, we need to tamper with how NUnit actually works. And this can cause a lot of problems because it's very easy to just introduce an error here. So if done perfectly, it is possible to get these attributes. It would be a bit slower. It is possible, and then we would need to use additional handlers and hooks to actually create different functionalities based on which attribute is on the test. So all the methods that would be in a test would have a lot of abstraction in the background under the hood for all the different attributes, and that's so much complexity on top of an already pretty big and complex framework. And it would make it even harder for people to get introduced to the project. The people themselves would make it harder for them to actually navigate the project itself, to debug the project if needed. And this just didn't make that much sense. So while we did consider it as an initial idea, we quickly moved on for this, our attribute-based approach. So what we went with next is the DeltaSky approach. So because of this, the DeltaSky approach is actually what you saw in the designs, the depictions in the initial idea and stuff, and those diagrams at the start. So what we have as a process of the DeltaSky approach is the design patterns are much easier to be implemented. So you want page object model, you can use page object model. The web tests are stored in a different part. So they will be individual to the API test. They won't have anything in between them. So you can use all the design patterns that you like for the different tests. You can use page object models, screens for tests, whatever you like for API. So it's much easier to go there. The next thing is If you already have an existing framework, it's much easier to just update it to this. You don't need to spend so much time to do the abstractions, to get all the attributes from the tests, to do all those under the hood stuff. You have one, you just add the other classes, you make the whole framework from the start, and you just implement the DeltaSky application itself. It's much easier to use and it goes much faster. And in the end, because we have this easier to use system, not complex system, we don't have that much abstraction. The onboarding itself is much easier. New people, when they come, it's much easier for them to get very intimate with the project itself. The knowledge transfer is much faster, it goes much smoother, and I've seen people get adapted to the framework itself much, much faster. Of course, there's nothing without a bad side, and the con for DeltaSky is that multiple test classes means that when a functionality is changed across platforms, all the test cases must be changed. And this is where it comes where we have similar test cases across platforms, and while on the attribute-based approach, we will just change one test and it would go through all the other platforms. Here we would need to visit each different class with each test and just change the test there. And the bad thing here is that we're all humans. We can make a mistake, and this is where the mistakes might happen. This is where we change some of the tests, but not all of the tests. So some platforms start running on all tests, and then we have some errors, and we start to think that the app is bad, but it's actually the tests that are giving false results. Okay, let's continue now. So let's see some examples of these two approaches. So on the left, we have DeltaSky approach, and on the right, we have an attribute-based approach. As you can see, the attribute-based approach, we're using a separate flow that would actually guide us through all this. So we're not using Cucumber in this instance. And because of that, we have like another layer on top of it that will actually regulate how the test steps go and how they move through the steps itself. So I'm a big fan of the chaining in function in the test. So yeah, that's why they're all chained like that. Okay, so let's see. This is pretty simple. We want to change the currency from euros to dollars, from dollars to euros. So let's first start with the attribute-based approach. So what we do is we start with it, we go to the screens, we change the currency, we change it to euros, then we go back and then we check that the prices are actually shown with euros. And we check the prices themselves. However, while this might work for the web and the mobile, it doesn't quite ring that much of a bell for APIs, right? Because it makes no sense. You don't have where to move on the APIs. You don't wait to change something. You just make a call and you see what the code returns. So in this case, for this tests like these, we would actually need to get crypto to get the data in euros, to get the data in dollars, then to get the conversion scale, and then to verify that our prices are good in euros as they are in dollars. And for this, we would have two tests that are basically checking the same functionality. So you would actually have the same function, the same name for the test, so that you can easier find it. But then you just need to add something like to, in this case, I've added, or API or something like that. And it doesn't make much sense to have all these tests into one class. So on the other hand, the DeltaSky, so the category and which categories are used, that's already implemented in unit. So we don't need to look more into it. And it's just, you know, what's another way to add tags. Then we go into the tests themselves, and these tests make much more sense. So we actually go and this is for a mobile test for Android. So we actually have all the tests. We go to the profile screen, we change the currencies, we return back, we check the prices, we check that the prices are in euros. And then we have a separate test into the API tests. That's also for this thing where we convert stuff, and we actually see we actually get the dollars and the euros, and we check the prices there. So it goes much smoother. We can use whichever approach we like for the API test, for the mobile test, for the web test. So it goes much smoother and much faster. So it definitely paid out that we went with the DeltaSky approach in the end. If you're wondering why it's so much cryptocurrency and everything, the app we were testing was about cryptocurrency. So that's why you see so much currencies, euros, dollars, and stuff like that, so that you don't get confused. I didn't mention that at the start. Okay, so how do we run the test? What do we actually do? So we implemented DeltaSky as a console application. It's pretty straightforward. So if we're running on a local machine, we actually tend to delete all the past hour report files because we don't need them. We just want to see the new ones. We have separate functionality if we're running them on the cloud, on the AWS, etc., in the CI/CD, so that we don't actually delete them. But yeah, and the way it works is we choose if we want to run just certain tests. We went with an NUnit filter to do this. So why an NUnit filter? You might ask, and it was pretty simple. Everyone's already introduced to that NUnit filter, so everyone knows that one. And it didn't make sense for us to introduce a whole new filter, where after we get the user input, we then change that into an NUnit filter so we can pay it out to NUnit to send it to NUnit API to start running it. So in this case, we went with the basic NUnit filter, and we can just straight up send that to the test, to the CI/CD, to the application itself. And then we just run the test runner. What a test runner actually does is pretty simple. So it just starts the engine, reads the package. At the moment, because we're just using our own app, we actually have where the tests are hard-coded. There is also an option if you'd like to send the line to send the location, but it just seemed unnecessary for us at the moment. And then we create the filter itself based on if we had something, if we had entered an NUnit filter beforehand, we would get the filters, or if not, we would just start all the tests. And then the engine itself would just run all the tests that satisfy the filter in the package that we sent before. So pretty straightforward. Create an engine, create the package, and then just the engine starts the runner according to the package and the filter itself. Pretty straightforward implementation as well. At least, luckily, they had a lot of documentation on this. Okay, so now that we got that out of the way, how do we run them? The developers create their own tests. So what do we do? How do we use the AWS for CI/CD? So we're using the S3 buckets for storing past reports and screenshots. So there's also optional flags on the test themselves if we want to save screenshots from the mobile, from the web apps. That's all enabled. Then we're using the SSM from AWS for storing all the credentials or the sensitive information that we have. They're all stored there. Next, we're using the code build for running the test. So this is where we build the tests and run them. And the tests themselves are actually run on an instance of EC2 from AWS. So it's not as simple, but it's not that complex as well. Okay, so let's get to the interesting part, all the reports. So we're using Alert reports, and the good thing about Alert is that allows you a lot of stuff. So you can get an easy overview, how many tests have passed, how many tests have failed, different suits, different graphs, different categories. It gives you everything. So for this screenshot here, we can see all the tests that have run, how long they've lasted, and on the right side, we can actually see all the output of the tests themselves. We can see that the mobile tests are a bit slower, but such are the emulators, so there's not much we can do about that. We can see the UI tests, the API tests. We can see sort of a log. This is from one of the UI tests, the log. So what we're doing, how we're doing it, what we're accessing, why we're accessing it, all that's part of the framework that we've built, and it just logs everything here. Pretty straightforward. And this is the timeline. This is a very good thing that Alert actually offers, and it's the timeline of where the tests and when the tests have run. It's pretty good because I see that, well, we can actually see here that the tests are run in parallel. The tests are run in parallel in that way that for each category we have the tests running. For example, the first tests are the API tests, then we have the web tests, and in the end we have the APM tests. And we can see that they all start at the start. We can see how long each test lasts. If you actually take a closer look, we can actually see that the tests and when they start and when they finish are actually here, and we can see them. So for example, for the web ones, we can see that we have 3 tests. For API, we can see that we have 2 tests. And this is only a small timeline, so the IPM test is still continuing here in that direction, but it's not the whole timeline of the, in this case. And this is pretty good that it offers. It can also give you like an example of which test you want to see, which test you don't want to see, like timeline of the tests. For example, you can choose that you don't want to see tests under 2 minutes or under 20 seconds. So it gives you a lot of options, and that's why we went with Alert. It's actually pretty easy to use for C# and gives you a lot of information. So it was a pretty easy choice to make. Okay, so we went through pretty much most of the presentation, and what would be the next steps? And well, this is what we were thinking, and the idea we came up is that there are many projects where we need cross-platform testing, and it can be very daunting to start that experience and to venture into more deep into it. So we thought of creating actually a console application that you can run, and it would be pretty simple to do. So you just select the path to the test DLL, so we send it here in the first field, and then in the second field you just enter your n-unit filter, which test you want to run, which test you don't want to run, and then you just click OK. And then the application itself, the console app that would be built, would actually get the test DLL, get all the tests, filter them as to your n-unit filter liking, and then just run them in the background. So it offers you all that out of the box, and this is what the next step would be, where we plan to go with this application. I don't know, to me it seems like a very interesting idea, something that would be pretty useful.